All right. So the next step I need to consider here is how to do the webbing in between the structural arms and how I want to do the actual suspension cables. The what I can glean from the condition that I see here is that the suspension cables are more or less aligned with the control points of the webbing. So that means that the way that I develop them is kind of gonna they're pretty much gonna speak to one another in terms of how I develop them. So here in Grasshopper, actually one of the first things I want to do is kind of lessen. Actually, what I'm noticing is that the curvature of these profiles is sort of weird. So I think first and foremost I want to increase the number of perpendicular frames. And I can do that very quickly just by changing this to 10. You'll see that it kind of smoothed it out here in the front end. I'm just doing that as a precautionary measure. So the webbing. The webbing is very important because we have to determine how we establish basically the control points are going to be built off of, how do I want to describe this? We can do it by using a subdivision of points along the curve, and then we can kind of map all the geometry to one another. Or we can do it using like surface subdivisions and stuff like that. I think one of the smarter ways of doing it in this case is going to be a point-based extrusion system. And so yeah, well, actually, here's one of the... I want to... Yeah, let's do it point-based. Let's do a point-based. I wanted to kind of make it more visual and do a surface and you know, re-parameterize the domain down and kind of see where the whole webbing system was going to be, but I don't want to do that. So we have essentially the interpolate curves. That's a really important thing to know. And in order to understand what's happening here, I'm going to go up and turn this stuff off so that I can really understand all this stuff. I'm going to leave everything but the interp curves off. So I'll just turn all this stuff off. And just to simplify everything here, I'm going to grab a curve param and take it from the interp curves. And I'm just going to call this arches. Or just arch curves, whatever you want to call it. Something like that. And I'm going to make that wireless. Here I go, pulling it down. So just like the domain reparameterization, we should be able to reduce the parameter of the curve, I think. I haven't done this before, so I'm just going to go up into my curve and analysis tools and see if there's a way to reparameterize it downward. I might need to do it with a surface reparameterization. Utility. Explode curve into smaller segments. I could do something like that. Polyline collapse reduce. No. Probably explode, but I don't think that's parameter based. Yeah, I don't want to do that. Let's go back to analysis and see. Evaluate a curve. Actually, hang on. I'm not sure how to do this on a curve. Alright, so the easier way that I think this can be done, just because I'm having trouble figuring out how to just reparameterize a curve alone, is to actually loft the two edges into a surface, which will give me you know, a surface between the two that I can then reduce from the edges proportionally. And then I can grab the newly reduced rails if I choose to do it that way, or I could subdivide that surface and then do like some cross webbing and stuff like that. And in fact, we might use both. It might be easier to do both. So the key here is to isolate the correct sides. So I want to loft this one to that one and then that one to that one. So I will try right off the bat just splitting the list. So I'll go to surface, sorry, no, set, list, split list. And I'm just going to say arch curves are going to go in. I'll flatten that. And the index is going to be a value of 2. And then with the curve param, I can test whether or not they're both on the same side, and they are not. So that tells me I cannot use split list. Yours might be, but mine is not. So I'll get rid of that then. So with this, I think the best way to do it is probably just with 4 list items. And I can do that now because this is easy enough. There are only 4 items here. So set, list, list item. And I'm going to put a slider from 0 to 3. So this first item is the front side on the right. This second item is the back side on the right, so I'm going to move this one down to the bottom. Copy and paste this one down. And this one is the back side on the left, so I'll move that one to the bottom here. And then this one, index item 3, for me, index item 3 is going to be this one. So just get it to be organized so that you have the 2 rails over here and the 2 rails over there. And you should be able to simply take the ruled surface command, and it should just kind of connect the 2. So I'll plug those 2 in like that. And I'll grab another one, plug these 2 in like that. Any questions? Let me pause while you get caught up. All right, now, so with these ruled surfaces, the key is we're using this to reduce the position of the rails. So that way I can basically take a surface that starts about here and ends about there, and I can use that to subdivide and then create these cross members. That's my goal anyway. So I need to do that through a domain function known as, do you guys remember? Do you remember what domain function we need? Close, but no. Construct domain squared. So if you remember, divide domain squared is the one that you use with isotrim, and it breaks it down into subdivisions, which we might use in a second. But first, if we're going to try to reduce the overall size of that surface in its position, just kind of like chop some of the edges off, we are going to do that using construct domain squared with isotrim as well, but we're going to reparametrize it. We're going to use that a lot here. So construct domain squared. We're also going to need surface utility isotrim. And make sure that you put your sliders appropriately from 0 to 1.00. So I'm going to say slider 0 to 0.55 to 1.00. Oh, darn. I'll kind of pull it back there a little bit, I guess. And the surface is the ruled surface, and then the domain is that. And just make sure that you reparameterize the surface itself and pull this back and forth. That's key. So make sure you pull these back and forth. Then reparameterize. So what's going to happen is you're going to reduce the overall domain. And so here my U value, for me, my U value is going in the long direction of the surface. So I'm going to pull it up to about there, and I'm going to pull this one back to about here. In fact, that one's going to go a little higher, I think. Something like that. And then the V direction, because I want it to reach out exactly to either side, I'm going to max those out at 0 and 1. Likewise, I'm going to copy this whole thing down. And replace the next ruled surface in there. And I'm going to use the same values. Actually, I don't need to copy the whole thing down because I'm just going to make sure that my values are the same in either instance. So I'm just going to take the same domain and put it down there. So why am I doing this, right? You might be curious why I'm doing this. If you turn off this stuff right here and you go back to your original definition and you turn on your lofts, this is essentially why. I am creating a surface that I can use to subdivide. And so you mentioned using divide domain squared before. Well, I could use that here in order to generate the information that I need to make the x's, essentially. And so that's going to be the next step in the video. Questions? No questions? Okay.